Okay, so today we're going to be doing domain and range. So domain basically refers to all the values in the x direction, and range is all our y values. So when asked to state the domain and range of a specific relation or function, they basically want you to define or explain or say that, listen, this is what all the x values are allowed to be, and this is what all the y values are allowed to be. So let's look into one. Let's have an example. It's not perfect. Let's do and say we have at 1 we have 2, and then at 2 we have 3, and then at 3 we have 4, and so on. So let's say we have these points, right? And these points are, if we were to map them out as x and y coordinates, at -3 we have a value of -2. At -1 we have 0. At 0 we have 1. At 1 we have 2. At 2 we have 3. And at 3 we have 4. So now we're going to basically write the rules for domain and range. Let's start with domain. The domain for this is basically what are our x values allowed to be in this particular set. This is a limited set, so we only have these 7 points. So we can write our domain is equal to literally these points. And same with our range. So we can write -2, -1, 0, 1, 2, 3, 4. Or there's another way to write this. We can write x is equal to all the integers between -3 and 3. So this then, well, this basically means this. X is all the integers in this range. Domain, but like within these two numbers. We know that from -3 to 3, it's every integer. And same with the y. sign here. This means A is less or equal to B, or B is greater or equal to A. That's what this sign means right here. And the opposite is exactly what you think it is. Well, yeah. Basically whatever's on the opening side. That's what this means. So yeah, because we do have values of 3 and -3, so we do use the equal. If we were to use, instead of this, we were to use just this, it means B is strictly greater than A, and they cannot be equal. So, yeah. So in that case, you could write this as -4. So the integers greater than -4 and the integers less than +4. So yeah, that's one example. Let's do another one. Let's do one where we have, let's say we have -5 and we have a +5 and a +10. Let's say we have a line, let's say that's 5. Let's make another line here that goes from -5. I'm gonna draw an open circle and let it go till there. Oh no. Ignore that part. Oh, let me draw that again bigger. Let's draw this, and it goes to here, and that's a closed dot. And then let's do somewhere here, let's make another one, an open dot, and go till just past 10. Okay, now that we have this, let's look at the domain and range for this function. So one thing that I want to point out is that when you have an open point like this, it means this point is not included, but a closed point is included. So when we look at the domain for this, and let's say this line happens at 2 and this line happens at 6 on the x, so right away we know the range, our range, our y values for this particular function can only be 2 or 6. There's nowhere else that y value is going. But for our domain, we have from -5 to 5. That's one domain, right? But remember, the open one is not included, so it's not. So from -5 to 5, this 5 is included, but this 5 is not. So if you were to write that, we could write is because you'll notice I didn't put the equal sign here because this negative 5 is not included. But this 5 is, even if this one is open, this one is included. But let's say this ends at 11. So actually, the range will continue all the way to 11. And that is the domain and range for this particular function. Let's do one more. Or even maybe two, but let's see. So let's say we have let's say at 3, 1, we have a parabola that opens up. Sorry, it is 1, 3, x and y. So now the domain and range for this. Let's look at the range first, or let's look at the domain. The domain, as we can see, as this continues, this will go on forever in that direction, and this will go on forever in that direction. So our domain is XER, and that basically means all, like any real number, x is equal to all real numbers. And then for our range, we just have to look at x is all real numbers, and the only restrictions we have, because from here and downwards we have all our y values, but from 3 and upwards we don't. So, oh no, I don't know why I put x, it should be so the only condition we have here is that our y value can only be less than 3. And that is the domain and range for a parabola. And if you wanted, we could even do, let's say we had a circle with a radius of 5, and its center was at the origin 0. Now, we know that our x and y values will go all the way from, like say, let's do our x first. Our x can be all the numbers from -5 to 5. We have a value for every x. Same with y. So for a circle, it's very easy. Our domain is XER. Let's do -5. -5 to 5, and same with our y. And that has been domain and range for h for a function after solving it or something. But basically just look at all the x and the y values, what they can and cannot be. One thing you'll notice is that I went from xei to xer. When I say I, that means integer. So I use that for this one here. These are integers because I have plot points. I don't have anything in between. So I don't have a negative 2.5 for x or a 0.5 or 1.5. I do have integers. Integers are strictly 1, 2, 3, negative 1, negative 2 are whole numbers. But when I use xer, this is x is equal to all real numbers. So real numbers, any number. It could be to any number of decimal points. It could be here, 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 here. Like, yeah. Well, I just noticed I could write this as I. But yeah. Sorry about that one. This one. Our range. Yeah, our range is YE. That should be R. Sorry. That should be R. This could be YEI. Well, that's not necessary. We only have 2 points there. But yeah, I hope this made some sense. And I shall see you in the next one.